Next topic is corona formation in transmission line. When a high alternating potential difference is applied across two conductors, corona is formed. And the voltage at which corona occurs, it is called critical disruptive voltage, denoted by Vc. So the conductors will be surrounded by a faint violet glow, and the phenomena of corona is accompanied by a hissing sound, ozone gas production, and there will be power loss and communication line interference. So corona is the phenomena of violet glow, hissing noise, and production of ozone gas in an overhead transmission line. How this corona occurs? During normal conditions, the air is in ionized state due to some cosmic rays, ultraviolet radiations, and radioactivity. That is, the air particles consist of some ionized particles, that is free electrons and positive ions, and also neutral molecules. And when the potential gradient at the conductor surface reaches 30 kilovolt per centimeter, which is the maximum value, and when it is converted to RMS value, it will be 21.2 kilovolt per centimeter. So when a potential gradient of 30 kilovolt per centimeter appears across this conductor surface, the velocity of the electrons will increase and it will strike more neutral molecules, liberating more number of electrons. This produces another ion, and this will accelerate, and this will again collide with another neutral molecule. So this is a cumulative process, and this production of electrons will result in corona. So let's see which are the different factors affecting corona. They are atmosphere, conductor size, spacing between conductors, and line voltage. Atmosphere. In stormy weather or cloudy weather, the number of ions around the surface of the conductor will be more than the normal case. So in such conditions, corona formation will occur at a much less voltage compared with the normal fair weather. And second one is conductor size. Corona depends upon the size and shape of the conductors. That is, if the conductors are rough or irregular, then corona will occur at a much lower voltage. And stranded conductor has irregular surface, and it will give more corona at a lower voltage than a solid conductor. And third one is spacing between conductors. If the spacing between the conductor is made very large, corona can be minimized. Then line voltage. Line voltage is also another factor which affects corona. That is, if there is a high line voltage, corona will be more. Next, let us study some important terms related to corona. First one is critical disruptive voltage, denoted by Vc. Critical disruptive voltage Vc is the minimum phase neutral voltage at which corona occurs. So corona occurs at this voltage. And let us see what is the equation for critical disruptive voltage. So consider two conductors having radius r centimeter and they are spaced d centimeter. And if V is the phase to neutral potential, then potential gradient at the conductor surface will be G. So potential gradient G will be equal to V by R into log E d by R. We know that potential gradient is V divided by some distance. So here potential gradient is given by G is equal to V divided by R into log d by R, volt per centimeter. So to form corona, this potential gradient G should be equal to the breakdown strength of the air. Then only corona will form. So G should be equal to breakdown strength of the air, then corona will be formed. So the breakdown strength of air at 76 centimeter pressure and temperature of 25 degrees Celsius is 30 kilovolt per centimeter and is denoted by G naught. So breakdown strength of air is given by 30 kilovolt per centimeter. So it is G naught. So the potential gradient should be equal to the breakdown strength of the air, then only corona will form. So in this equation we have to substitute G as G0, which is the breakdown strength of air, and its value is 30 kilovolt per centimeter. So G0 will be equal to Vc by R into log E d by R, and Vc is the critical disruptive voltage, that is the minimum voltage at which corona occurs. So from this equation what will be Vc? Vc will be equal to G0 R log d by R. So here G0 is the breakdown strength of air at 76 centimeter of mercury and 25 degrees Celsius, that is the standard conditions, and it is given the value of G0 is 30 kilovolt per centimeter, which is the maximum value, and when it is converted to RMS value, that is Vmax by root 2, will give the RMS value, which is 21.2 kilovolt per centimeter. Thus we get critical disruptive voltage Vc as G0 R log d by R. So this equation of critical disruptive voltage is under standard condition, that is 76 centimeter of mercury and 25 degrees Celsius. So if the condition changes, then we have to include some more factors, that is if for barometric pressure B centimeter of mercury and for temperature T degrees Celsius, then the breakdown strength will be equal to delta into G0. So before it was G0, if the condition changes, that is if the barometric pressure and the temperature changes, then G0 will become delta G0, and delta is the air density factor, which is given by 3.92 B by 273 plus T. So for some barometric pressure B and for temperature T, here we have to substitute this value B and T, then we will get air density factor. So for under standard condition, this value of delta is 1. That's why here we only considered G0. For another conditions, we have to consider this air density factor. So in this equation, we have to multiply G0 with delta, then the critical disruptive voltage. For other conditions, it will become G0 into delta R into log d by R. And considering the surface conditions of the conductor, we have to include M0, which is irregularity factor. So M0, then the equation will become Vc is equal to M0 G0 delta R log d by R kilovolt per phase, where M0 is equal to 1 for polished conductors, that is for polished smooth conductors we do not have to consider M0 because its value is 1, and for dirty conductors its value is given by 0.98 to 0.92, and for standard conductors 0.87 to 0.8. So considering the surface conditions, M0 value changes. Next important term is visual critical voltage. So before we see critical disruptive voltage denoted by Vc. Critical disruptive voltage was the voltage at which corona occurs. Next, visual critical voltage denoted by Vv. Vv is the minimum phase neutral voltage at which corona glow appears all along the line conductors. So visual critical voltage is the voltage at which corona glow appears all along the line conductors. So the visual critical voltage Vv is given by Mv into G0 into delta R into 1 plus 0.3 by root of delta R log d by R kilovolt per phase. Here Mv is another irregularity factor having value 1 for polished conductors, and for rough conductors it is 0.72 to 0.82, and delta is the air density factor. G0 is the breakdown strength of air, and its unit is kilovolt per phase. Next, power loss due to corona. Corona will cause power losses in transmission line. So power loss is given by the equation 242.2 into f plus 25 by delta into root of r by d into v minus vc the whole square into 10 raised to minus 5 kilowatt per kilometer per phase. So here f is the supply frequency, then r is the radius of the conductor, d is the spacing between the conductors, v is the phase neutral voltage which we have to substitute in RMS value, and Vc is the critical disruptive voltage RMS per phase. So this is the power loss equation for power loss due to corona. Now let us see the advantages and disadvantages of corona. The advantages are corona reduces the effects of transients produced by surges. And the second advantage is due to corona formation the air surrounding the conductor becomes conducting and hence virtual diameter of the conductor is increased. So consider this conductor. So after corona formation the air surrounding this conductor will become conducting. Thus the virtual diameter of this conductor increases, thus the electrostatic stress between the conductors decreases. And the disadvantages are corona increases the power losses in transmission line, then corona produces ozone gas. So ozone gas formation will lead to corrosion in the conductors, and it also causes interference with the communication lines because the current drawn by the transmission line due to corona is non-sinusoidal in nature. So there will be harmonics and voltage drop will be there. So interference with communication line increases. So these are the advantages and disadvantages of corona. Thank you.